Hello, and thank you for joining us for the SLW Institute webinar, Drafting U.S. Patent Claims for Artificial Intelligence Inventions in Healthcare. A recording of the webinar and the slides will be made available to all registrants. Feel free to enter any questions using the Q&A feature in the Zoom menu. We invite you to follow us on LinkedIn to see news about other upcoming webinars. Our speaker today will be Greg Rabin. Greg is a senior patent attorney at Schwegman, Lundberg, and Worcester. Greg's practice is focused on computer science and software inventions. Greg holds a JD from the University of Michigan Law School, dual bachelor's degrees in computer science and mathematics from MIT, and a master's degree in computer science from MIT. Greg is also the named inventor on 5 patents. Greg has spoken about patenting inventions in artificial intelligence and machine learning before the American Intellectual Property Law Association, the United States Patent and Trademark Office, and several CLE providers. And with that, I'll turn things over to Greg Rabin.
Thanks for the introduction, Michelle. So I'll be speaking about drafting U.S. patent claims for artificial inventions in healthcare. You can see my contact information on this slide. If you have any questions with which you want to contact me directly, feel free to email me or call my home office number or contact me via LinkedIn. So artificial intelligence is coming to healthcare and other industries, as you can see from the healthcare card from the Dilbert cartoon here. The artificial intelligence already made its way into coffee makers that manipulate people into making a fresh pot if they take the last cup. And once it gets to hot coffee makers, you understand that it's going to get into healthcare also. So to outline the presentation, I'll start with a brief introduction, then I'll go over some relevant US case law. Then I'll speak about written description and functional claiming with artificial intelligence, and that will lead us into some sample artificial intelligence patents in the healthcare field, and I'll discuss the claims in those patents and how I believe they could be improved and what I believe the drafting attorney did well and did not so well. So with that, I'll move into the introduction. So this slide here illustrates the training and use of a machine learning program. This machine learning program, basically the features are message words, message concepts, and message attributes in the subject, communication history, past behavior, send information, user data information. So this machine learning program is processing, for example, email messages to determine which folder they should be placed in or whether they are spam or not spam. And the machine learning program is given some training data, and based on the training data, the machine learning program learns to appraise features so that when it sees a new email message, it's able to use the features to determine whether or not the message is spam or which tab the email should be placed in within the Gmail program or similar programs. And this information is fed to the trained machine learning program and along with any new data that it receives, and the machine learning program generates an assessment that tells the computer whether or not the message is spam or which tab it should be placed in or any other classification of messages. So some general rules that I like to keep in mind when drafting machine learning patent applications is to not leave the invention out of the claim. Machine learning inventions are generally described as being a black box where there's some input that goes in, and then the black box does the magical processing, and then at the end it determines whether or not the email message is spam or some other classification of the message. And we don't know what the black box does, but in the claims you want to claim how the black box operates, not just what it does. So instead of saying that the message is classified as spam or not spam, you want to state in the claim exactly how the message is identified as spam or not spam, what features did the machine look at, what calculations were done with those features, and how did we arrive at the result. And also, it's a good idea to, as much as possible, and definitely in the specification, tie the technology to a practical application in order to balance the trade-off between breadth and patentability. So one approach could be to have a teaching claim where you basically teach the reader of the claim, the examiner, and potentially a licensee or a member of the jury in the future what the technology does in the beginning, and to have a broader claim later on, like maybe claim 7 or 8 could be a broader claim that focuses more on breadth, and in that case you get both breadth and patent and a teaching claim that teaches the reader exactly what the invention is doing and how it works. And another thing to consider is detectability and infringement scenarios. For example, oftentimes in machine learning, the real invention is in the training phase. For example, in self-driving cars, the real invention could be in training the car to drive itself, whereas the most infringement is going to occur where people are actually driving the car in the inference phase, where the car is actually on the road after it has been fully trained. So you want to consider detectability. As I mentioned previously in discussing the black box, machine learning algorithms are often described by the inventors as being a black box where there's some input and some output, but you want to be able to write the claims in a way that it is possible to adequately allege infringement in the amount of discovery that you're able to do before getting to litigation or before beginning to negotiate a licensing deal for your technology. So some patent prosecution obstacles that you can encounter is that patent examiners don't like the word model because anything can be a model, and you want a technology that focuses on exactly how the learning based on the data is done or what heuristics are used in order to determine the result. And another thing that patent examiners like to say is that the technology can be done with a pen and a paper, and therefore it's something that can be done in the human mind, and it's not valid under the Supreme Court's latest interpretations of 35 USC section 101. And there can't be machine learning without a machine, so if at all possible, you should tie your claims somehow to a machine or to hardware within the machine so that it's clear to the patent examiner when they're reading the application and reading the claims that this is being done using a computer rather than a person working with a pen and paper. And the person is assumed to have, of course, unlimited time, unlimited computational resources, and unlimited coffee because they never get tired of doing these calculations. And you also want to focus, especially today when there's a lot of prior art in the machine learning space, just any mention of machine learning in prior art could imply that all applications of machine learning are covered. So you don't want to basically say we're using machine learning to determine if a picture includes a cat. You want to specify like how technically you are identifying whether there is a cat or there isn't a cat, and what technical details are being used in order to establish novelty from previous cat recognition technology, patent applications, or other machine learning applications where there's some kind of image recognition being done to determine whether there is or isn't a cat in a given image. So now I will speak about some relevant US case law in the artificial intelligence and machine learning space that could be applied to healthcare. So one of the most famous cases in this space was the Enfish v. Microsoft case, which was decided by the Federal Circuit in 2016. And this case covered the 2 US patent numbers you see on the screen, which recited a self-referential table, which is a special type of data structure that's designed to improve the way a computer stores and retrieves data in memory. And there were claims that covered means for configuring this self-referential table. And the specification described a 4-step algorithm that configured the self-referential table. And basically, the Federal Circuit decided that these claims were eligible because they were directed to an improvement in the functioning of a computer, and the claims show the specific improvement to computer technology rather than a pure application of computer technology without reciting anything that tied the invention to an improvement in how the computer itself worked. And another case is Thales Visionix v. United States, and this claim covered an inertial tracking system for tracking the motion of an object relative to a moving reference frame, and there were sensors that calculate the position, orientation, and velocity of the object in a 3D space. And the Federal Circuit found that these claims were patent eligible because they used the inertial sensors in a non-conventional manner to reduce errors in measuring the position and orientation of the object. And this claim was focused not just on generating data, but on the application or use of data. So instead of focusing on the database itself, it focused on how the data was used, and a different database could have been used to train this model, and perhaps a slightly different model would have resulted as a result, and slightly different calculations would be made using the different data. And if you look at the claim, basically there's an element adapted to receive signals to determine the orientation relative to the moving reference frame based on the signals. So this claim focuses on how the calculation is done rather than simply saying what happens. It's explaining how the computer is making the calculations. And the next case I'll talk about is McCrow v. Bandai Namco. And in this case, there were two patents that claimed automating parts of a pre-existing 3D animation and automating the facial expression of animated characters through rule sets. And the court found that the process recites a combined order of specific rules that renders information into a specific format, and therefore it is patent eligible. So once again, this goes back to the point that I made earlier that you should include implementation details in the claims in order to have the claims be patent eligible. And if you look at the claim here, basically the claim covers a method for animating lip synchronization, and it uses a first set of rules that define output morph weights that stream as a function of phoneme sequence and the time of said phoneme sequence. So once again, it's focusing on how the invention is implemented rather than simply what is the input, what is the output, and stating that there's a black box. There's a lot of implementation details all through this claim, which you can read, including the two generating steps and the applying step. So the next case I'll talk about is Vehicle Intelligence and Safety v. Mercedes-Benz, and this covered a single patent which claimed a method in the system to screen equipment operators for impairment. And the claim basically recited an expert system that detects potential impairment in an operator and controls the operation of the equipment if the impairment is detected. And the Federal Circuit Court decided this patent was invalid because it was drawn to a patent eligible concept, specifically the abstract idea of testing operators for any kind of physical or mental impairment. And basically the court thought that this was a black box. Basically there's an input, which is data about a vehicle operator, and then there's a black box that somehow processes data, which the invention called an expert system, and then there is an output which states whether or not the operator is impaired. So if we take a look at the claim, basically the claim recites a method to screen equipment operator, and it basically says that there's an expert system that selectively tests the operator and controls operation of the equipment if the operator is found to be impaired. But it's not stating how the expert system how the expert system determines whether the operator is impaired and what calculations are done and or how was the system trained to do this. There's no, basically the claim is relying too much on black box, and there's no connection with exactly how the computations are done in order to determine whether the vehicle operator is or isn't impaired. So now I'll talk about the written description and functional claiming with artificial intelligence. So basically 35 USC section 112 talks about written description and means plus function claiming. So 35 USC section 112A requires that the specification include a written description of the invention and the manner of making and using it in such full, concise, and exact terms to allow a skilled person in the art to make and use the invention after studying the patent application. And 35 USC section 112F allows for an element in the claim to be expressed as a means or a step for doing something without reciting the structure that actually does the step, and the description of the structure could be in the specification, and in that case, any structures that are described in the specification as being able to perform the claimed features will be read into the claims. So personally, I like to focus on method, machine readable medium, and system claims, and I generally avoid means plus function claims, but it's something to keep in mind if it will be valuable for some AI-related inventions. So before the Williamson case, there was a strong presumption that the claim had to recite explicitly the phrase means for in order for means plus function claiming to be invoked, and this was a strong presumption that is not readily overcome. And basically the limitation, the specification, the claim had to, the statutory construction on applying list limitation was essentially devoid of anything that can be construed as a structure. And after the Williamson case, this strong presumption was abandoned, and basically the William case that said that the limitation can be applied to any recitation in the claim that is devoid of anything that can be construed as a structure. And the new standard that the Williamson court applied was whether the words in the claim are understood by persons of ordinary skill in the art as having a sufficiently definite meaning as the name for a structure. And as you can probably guess, this language is very vague. So what was going on in the patent office since then is basically some nonce words were identified by courts as invoking 112F, and some other words that are not nonce words were not read by courts as invoking section 112F. So, for example, the phrase module for, unit for, or device for invoke 112F, but circuitry, processor, or computing unit do not invoke 112F. And I'll give you a moment to review all of the nonce words and non-nonce words in the slide. So MPP section 2181 says that that the specification must set forth an adequate disclosure of what the structure of what is meant by the language if one employs means plus function language in a claim. And the test is whether the corresponding structure of a means plus function claim is disclosed in the specification in a way that one skilled in the art would understand what structure will perform the recited function. And if not, then the claim will be found to be invalid based on indefiniteness. And there needs to be a disclosure of a structure that corresponds to any claimed function. And just disclosing a general purpose computer is not enough when the element needs to be implemented on a specific purpose computer. For example, a computer that needs to be programmed with some kind of algorithm or some formulas or some flow charts. And basically an expert declaration that a person of ordinary skill in the art with no structure is needed is not sufficient, and the four corners of the patent application would generally need to cover the information information that is in the claim, and to basically teach a person how to do the functions of the claim. Of course, if it's something very simple, such as storing data in memory, then any skilled programmer will know how to do that, and just the disclosure of a general purpose computer would be sufficient for that. But if you have a claim that recites receiving network data and processing the network data, then it's not obvious how exactly that would be done. So the claim element, so you would need to disclose the specification exactly what elements of the computer would do that and how those are programmed. And basically, a programmed computer requires a computer to program an algorithm to perform the specialized functions. And specialized functions are functions that are not known in the art, that require adding special programming to a computer. For example, an event detection system that communicates network event information requires disclosure of an algorithm for how events are detected and how the network information is communicated. And then there are non-specialized functions, for example, storing data, which a person of ordinary skill in the art would know how to do, and you don't need to add any specialized description to the patent application beyond disclosing a typical computer. So now I'll talk about avoiding indefiniteness when claiming AI. There was a case in 2015, Gradient v. Skype, which basically covered claim 27 of US patent number 7669207. And Skype successfully argued that claim 27 and its dependent claims are invalid under section 112F because the patent did not disclose adequate structure corresponding to the claim functions. If you look at claim 27, basically it covers a designation system that designates one of the mobile agents as a controlling mobile agent, designates another one of the mobile agents hosting another one of the nodes as the controlling mobile agent. And basically it's one of the dependent claim 29, that the designation system can utilize at least one of a voting and an artificial intelligence algorithm. But there was no disclosure in the specification of what exactly the artificial intelligence algorithm is, or any other discussion of how the designation system is programmed. So this patent was found to be invalid under section 112F. So now I'll talk about some sample artificial intelligence patents in healthcare. And to the best of my knowledge, none of these patents were drafted, prosecuted, or assigned to SLW or to myself. And of course, all statements about patent validity and patent scope are my opinion only and might not necessarily agree with the opinion of my firm and do not constitute legal advice. So if you're planning on infringing any patent that I say bad things about, then don't do that. The patent might still be valid. So the first patent we'll look at is US patent number 1035471. So this patent relates to deep learning medical systems and methods for image reconstruction and quality evaluation. It's assigned to General Electric, and claim 1 as allowed was almost identical to claim 1's originally filed. There was only a minor readability amendment made by the drafting attorney in the first office action. So to understand technology, you can look at figures 21A and 21B. Basically, in the training phase shown in figure 21A, there's a labeled image input layer that is provided to a convolution, a pooling, and a fully connected layer, and a softmax classifier, and it's mapped to a known image quality index. And in the inference phase, unlabeled images are provided to train the layers of the neural network, and image quality index values are calculated for the unlabeled images. And if you look at claim 1, basically claim 1 has an imaging system that includes a processor and a memory, and there's a deployed learning model generated from a training network. and the training network is tuned using features extracted from a set of labeled reference medical images, and there's a display to output the first medical image and the associated image quality metric. And I believe that the display and the features about training the neural network model has caused this application to be patentable because it ties the invention to a specific implementation and a specific use of data within a computer rather than a black box based implementation. And the display also is a physical device that's external to the processor and the memory of the computer, although arguably the display step could be a post-solution activity. So I think the first highlighted part is what helped get this patent application to be allowed. The next one I'll talk about is US patent number 10649-985, which is related to systems and methods for processing natural language queries for healthcare data. This application is assigned to Blue Cross, and it was allowed as filed. So basically, this invention, it processes a health insurance benefit book, and it allows basically natural language questions to be answered based on the benefit book. And you can see the training phase in Figure 1 and some details of the query processing system and the document ingestion system in Figure 2A. So basically, a benefit book document is provided to a document ingestion system, and the document ingestion system adds some structure to the benefit book in order to allow it to be processed by a query processing system, and then an end user communication device, such as a mobile phone or a laptop computer, can be used to provide queries into the query processing system. The query processing system will obtain answers to the queries based on the initial benefit book. So, for example, you have a page in an insurance benefit book that talks about what are my benefits, what's my out-of-pocket maximum, co-insurance, and calendar year deductibles. And in Figure 5, there's an illustration of how this data would be structured based on this page in the benefit book. And for example, a question could include a normalized intent as shown in Figure 7b. What will my out-of-pocket cost be for physical therapy? And then there's an answer template if deductible met, answer template if deductible not met. And basically, the computer uses the answer template to provide an answer to the question based on the benefit book. So now if we look at Claim 1, basically Claim 1 talks about basically ingesting a benefit book into a computer and processing the benefit book in a way to be able to process queries, and then receiving a query and generating a response to the query. And basically highlighted parts of the claim, which I thought were the most useful for patentability of this invention, are the set of structure tags, which explain how this processing is done rather than simply saying what is done. It explains exactly how the benefit book is processed in order to be able to handle queries, and then how a query is processed in order to obtain an answer to the query. So basically, there's a set of structure tags and a set of semantic tags that are added to the benefit book document, and then the computing device builds a graph of information within the benefit book. And then after receiving a query, there's a matching of the intent in the query to a template response, and then the template response is displayed to the user. So the next healthcare patent I'll talk about is US patent number 10478-112. This patent is titled Enhancing Diagnosis of Disorder Through Artificial Intelligence and Mobile Health Technologies Without Compromising Accuracy. It is assigned to Harvard College, and it was allowed after one office action, one response. And while this application was filed in October 2018, the priority date you can see is October 2011, so the claims are broader than what would be allowable likely if you were to file a new patent application in 2021. So here's claim 1 as amended in the office action, and after entry of this amendment, the office found it allowable. So basically, there's a computer implemented method for evaluating an individual for a behavioral disorder, developmental delay, or neurological impairment. And the method includes displaying a plurality of questions, receiving a input comprising a response to at least one of the plurality of questions, and generating using machine learning software an output comprising an indication of whether the behavioral disorder, the developmental delay, or the neurological impairment is present in the individual based on the input, and the output is determined by the machine learning software with a statistical accuracy of at least 90%. And so this claim, it's not very well tied into how the result is obtained, other than saying that it's done using machine learning software, and the result has a statistical accuracy of at least 90%. So I could potentially argue that this claim is indefinite, but of course, if we go back to 2011, then maybe just saying machine learning was sufficient in 2011 because there wasn't that much prior art related to machine learning software for diagnosing behavioral or neurological conditions at the time. So as I mentioned, the initial office action included a rejection under 35 U.S.C. 101 based on the Alice line of cases and 102, 103, and the applicant overcame these rejections after responding to the office action. And basically, the applicant argued that the method of claim 1, to overcome the 101 rejection, they argued that the method of claim 1 is a technical solution to a technical problem of accurately diagnosing and treating individuals with a behavioral disorder. And they focused on the fact that the result is generated by machine learning software with a statistical accuracy of at least 90%. And of course, this limitation makes it harder to allege infringement because you would have to prove that the infringing software also has an accuracy of at least 90%. And I'm not sure that I agree that the problem of diagnosing and treating an individual with a behavioral disorder is a technology problem, but these arguments were successful by the attorney drafting these arguments in the patent office. So there's disagreement within the field of whether this is a technical problem. And also, the attorney further argued that basically in the 2019 patent subject matter eligibility guidance, there's a statement that an additional element may be integrated into a practical application if it reflects an improvement in the function of a computer or an improvement in other technology or a technical field. And therefore, basically, the patent attorney drafting this office action response mapped the problem of diagnosing and treating a behavioral disorder to a technical field, and therefore argued that it should be allowable under 35 U.S.C. 101, and this argument was successful in the patent office. I'm not sure I would have agreed with it if I were the patent examiner, but this shows that it's clearly an argument worth making, saying that any field is a technology field in which could be used to overcome the 101 rejection based on the 2019 revised patent subject matter eligibility guidance. So what would I do to strengthen claim 1? If it were supported by the specification, I would have provided more details of how the machine learning software module is built. Is there a specific structure of the neural network? And I would provide details of the training algorithm or of the feature vector that was used to determine the training that was used by the training algorithm and by the inference algorithm. And I would remove the statement about the statistical accuracy being at least 90%. And Harvard later filed a continuation of this patent in US patent number 10.687.751, where they kept the classifier has an accuracy of at least 90% limitation, but they followed some of my other suggestions, specifically in the third paragraph. They said that to provide the responses input to the classifier, and they specified the classifier is trained with data from a plurality of individuals having the behavioral disorder, the developmental delay, or the neurological impairment. And the next patent I'll talk about is 10.682.093, which relates to a digital platform to identify health conditions and therapeutic intervention using an automatic and distributed artificial intelligence system. This patent application is assigned to Spiral Physical Therapy, and it was allowed as filed without any office actions or amendments. And this one was filed more recently in April of 2019. So basically, if you look at the technology, it's illustrated in Figure 1, where there is a server engine and there are physician terminal devices and distributed data collection devices and a data repository and a tracking terminal device, which is used by the patient. And all of this data is combined together via a network to assist in the patient's physical therapy. And if you look at Claim 1, it's a fairly detailed claim. Basically, it covered a scanning platform, which is external to the computer, and the scanning platform has a plurality of optical sensors and the force plate. And basically, the claim covered receiving body topography data for a target patient from the optical sensors, receiving force data from the force plate, and later the claim went into detail about which calculations are done with this data, including the quantized PHCI matrix and the health indicator vector in the quantized health indicator vector space, and basically quantizing the health indicator vector to obtain a quantized health indicator vector, and then obtaining a patient health condition vector corresponding to one of a plurality of pre-programmed health conditions. And basically, this claim is allowable both because of the specificity of the math that's being done by the computer and the external devices that are in communication with the computer. And if I were drafting this application, I would probably try to broaden Claim 1 by removing either the scanning platform and the optical sensors, and basically just saying that data is received at the computer and then the data is processed by the computer using the mathematical calculations that are recited in the claim. And that would be a broader claim, which should still be allowable based on the specificity of the calculations that are recited in the claim. So basically, how to strengthen Claim 1, to summarize, I would not claim the scanning platform, the data repository, and the communication interface as explicit components of the system, because this leads to divide infringement if all of these platforms are controlled by different entities. And instead, I would claim a system that comprises processing circuitry and memory that communicate with the scanning platform, the data repository, and the communication interface. And this assures that the invention can be performed within one computing device and avoids divided infringement. So the next patent that I'll talk about is 10.068.494, which was filed in May 2017. And this patent is titled Artificial Intelligence-Based Health Coaching Based on Ketone Levels of Participants. And this was was allowed after one office action and response and one examiner's amendment. So to summarize the technology, basically there are a plurality of users and they all provide ketone data to a breath analysis device, and the data is transmitted to an AI-based health coaching system via mobile device. And the AI-based health coaching system creates a trained model based on the user data records, the class definition, and its claim. The model is trained to classify records based on extracted features from the breath analysis and the user data records. So if you look at claim 1, basically, I think that the reason this claim was allowable was based on the highlighted paragraph at the bottom, which shows that the computing system is programmed with executable instruction to execute a trained model to classify the users based on the data records of the user, and the trained model comprises a feature extractor and the classifier, which were shown in the diagram in the previous figure, and it explains how the feature classifier and the feature extractor and the classifier both work. So overcome any 101 challenges. And now that's it for the substantive content of the presentation. You can see the disclaimer on the screen, and you can see a brief description of my bio on the screen now. And with that, we'll move on to the Q&A. See if I can open up the questions. So, was the fail claim considered as 112 paragraph 6? If so, did the court read the specification into the claim to result in non-abstractedness? I believe so. I think for all of the 112 paragraph 6 cases, they have to read the specification into the claims in order to result in non-abstractness, because otherwise, if you just have a means for claim and no supporting structure in the classification, then it would necessarily be abstract. So next question, if the invention generates information, is it proper to refuse a patent because there is no technology in providing info type data information? So if the invention generates information, then basically you would have to cover how the information is generated and tie the generation of the information to a computer, and ideally have some kind of outputting step where the information is either stored in a database or provided as output to a user, and ideally tied, as I mentioned earlier, tied the invention better to the computer itself. Would the application of machine learning potentially be patentable to reduce dependence on experts in scoring ice skating in the Olympics? So I think that would be similar to the physical therapy case and the breath analysis case that we discussed. So that would potentially be patentable. I would focus the claim on the features and the neural network, basically which aspects of the machine learning invention are novel and non-obvious. First examples are pre-Alice, what after Alice. So I think all of the examples that I went over would be patentable or patent eligible after Alice, with the possible exception of the Harvard case. And for Doug Carey asked for improvements in data processing and interpretation in medical science. when would a copyright be considered rather than the patent? So that's a good question. The copyright basically covers the exact code or the exact data stored in the database. So if you have some specific code or some specific database that you want to protect, then a copyright would be best. If you have an actual, like a technical improvement in data processing and interpretation that is technical in nature, then you probably want to think about whether you want to get a patent or a trade secret for that technology. And the patent versus trade secret, you want to look at whether you'll be able to protect the trade secret if a key employee leaves your company, and whether the technology could be reverse engineered or would be independently discovered by other people in the future. Were any of the allowed as filed cases filed with Track 1 or PPH? I don't know off the top of my head, but it could be looked up in public pair. I obtained all of these patent applications from public sources, so they should be available in public pair, and you can check if there was a Track 1 or a PPH filing. Could you please comment on the proper role of electronic circuit patent art in the rejection of AI algorithms? So basically, it would depend on specific claim that is being rejected. If there is a claim and there's an AI invention and the main component of the invention is an electronic circuit that is being used to implement the invention, then it would be fair for the patent examiner to look at prior art electronic circuits, and if there are prior art electronic circuits that are similar to or the same as the electronic circuit that's being used in the invention, that's claimed in the invention, then it would make sense for that claim to be rejected. So Ashley Sloat asked, I've heard many practitioners say that including updating and explain to XXX can be used to overcome 101. We haven't seen this as a viable solution. What are your thoughts to this end? So there was a Federal Circuit decision. I can't remember the name of the case, but there was a decision that said that basically improvements to display technology are patentable. So just simply updating a display to display a number or to display an image file stored within the computer by itself probably would not overcome 101. But if you have an improvement to a computer display, for example, if you're displaying information in a different way than it was displayed previously in order to optimize the allocation of resources on a small screen, then that might be patentable. Or if you're presenting information in a way that optimizes for navigation by the user, then that might be patentable as long as you can explain how the display is updated and how your update is different from previously existing technologies. Next question is, what about the use of neural networks already available as part of the training process? How detailed does it need to be described in order to provide proper support for a claim? So if you're just using neural networks that are ordinarily available, then you would just include some boilerplate description of neural networks and how neural networks work, how they're trained, and how the inference step is done, and you would include some new description of whatever aspects of whether it's the feature vector or some other elements that you can focus, that you can show that distinguishes your invention from the prior art, and that is where you should focus most of the disclosure. So if you go back to figure 1 in my slide, basically the invention could reside in any of the blocks, and whichever of those blocks you choose to focus on is the one that, let me see if I can find it. Find figure 1, it's close to the beginning of the slides. Here's figure 1. So the invention could be in the features, in the training data, in the machine learning program training, or in the trained machine learning program itself. And depending on which of the blocks the invention is in, that's the block you want to focus most of your attention on. So the 90% accuracy limitation has at least has the advantage of excluding trivial prior art. The limitation otherwise seems benign. Can you comment, please? So I think that, yeah, it definitely would exclude trivial prior art that is not very accurate, and otherwise it is limiting in terms of infringement, because for infringement you would have to prove that there is 90% accuracy, and in terms of prosecution, basically the examiner could just say that any technology could provide 90% accuracy, and you're focusing on the results rather than the technical steps of the invention. So the examiner could argue that this limitation could be ignored, and I would likely do that if I were the examiner in this case. And thanks for the presentation of the documents. Best regards from Munich. Thank you. And very interesting webinar, enriching. Thank you. I think I've answered all of the questions. So with that, I'll hand it back to Michelle.
Great, thank you so much, Greg, and thank you everyone for joining us. And we'd also like to invite you to join us for some other upcoming webinars. On Thursday, February 25th is the first episode of the Analytics How To webinar series, when we look at how to make and use portfolio analytics, patent landscapes, and patent watching and surveillance reports. And the second episode of the Digital Transformation webinar series will take place on March 3rd, when we examine an SLW digital transformation case study. It will be an overview of SLW systems, tools, data lake, processes, teams, and personnel. And you can find these registration pages on the SLW Institute on the SLW website. And please keep an eye out for the email invitations as well. And thank you again for joining us, and be well.